All right, so let's talk about order of operations. So this is something that you've probably come across once again, but order of operations is basically the order that we evaluate an expression, right? Or yeah, either an algebraic expression or a numerical expression, right? Normally, it'll be a numerical expression at some point or another when we finally fully evaluate it. And so, and you've probably seen some of these challenges that have come out, but like, just something like this. And so if it weren't for order of operations, this could come out differently, right? Depending on what order we operated, right? Like if you did 3 plus 4 first and got 7 and then multiplied by 5, you'd have 35, right? Which is different than if you were to multiply 4 by 5 first, right? And get 20 and then add 3, right? That's 23. So order of operations kind of gives us a standard by which we operate and make sure that we're consistent in the answers that we get when we operate and evaluate expressions, right? And so see if you know which one of those is right, okay? And if you guessed this one, you're correct, right? Because we multiply before we add and subtract, right? Even though we're used to reading left to right, we want to make sure that we do have a hierarchy of operations that we utilize. So, all right. So the first thing we do is we evaluate inside grouping symbols, right? Step 2 is we evaluate powers or exponents. Then we do the multiplications and divisions from left to right. And then we add and subtract from left to right, okay? And the left to right, with adding and subtracting, is not as crucial as step 3 with multiplication and division. But that's just something, if you go left to right, you won't ever be wrong in terms of multiplication, division, and addition, subtraction. Okay, so every time you look at an expression, you want to utilize that order. Okay, and a way to remember that, as you probably know, is PEMDAS, right? And sometimes people will use GEMDAS. So instead of P for parentheses, they'll use G for grouping symbols. And so you can utilize that if you want. I think I like GEMDAS better because I like grouping symbols because it's more broad than just parentheses alone. But PEMDAS is a little more widely accepted, so I usually introduce that in class. But I probably prefer GEMDAS if I had to choose, and it wasn't a matter of popularity and so forth. So P for parentheses, G for grouping. Either way you want to think about that. E for exponents. M for multiplication, D for division, right? And then we have A for addition, S for subtraction, right? All right. So here are some of the symbols that go along with some of these operators. So grouping symbols, we can have parentheses. Here we could have brackets, braces sometimes. Parentheses and brackets are probably the most common, but you could also have other symbols that are actually operators, like a radical, which conducts or conducts an operation, but also what's inside is grouped together. And so yeah, you would want to do what's inside first before you operate with the radical symbol. The same with a fraction, right? The numerator and denominator, even though you may not see the parentheses, the numerator is grouped together and the denominator is grouped together. So you'd want to operate within the numerator and within the denominator before you applied the fraction bar or the division, right? Same with absolute value. Whatever's inside there, you want to operate that first before you apply the absolute value. And then we have some other things that you'll see down the road. Sine, you may have seen sine and cosine and tangent and so forth, but what's inside there, the angle, the input of that function, that's considered inside a grouping symbol, and usually you'll see the grouping symbol with that. The same with the logarithm, that's called the argument, what's inside the logarithm, and you'll operate with that as well. And there's a few other functions that are similar to that. So with exponents, those are powers, right? So a lot of times you'll see them as just superscript. They're raised in smaller font than the other values, so that denotes an exponent. Sometimes you'll see this caret symbol denote a power. And so anyway, and then, there's kind of another version of exponents. They're the same, same version of this, but with constants instead of variables. So just to kind of go back to, this is an algebraic expression, right? This is a numerical expression. All right, and then multiplication. So there's a few different symbols for multiplication. We have the dot there, which represents multiplication. You can put things inside parentheses and next to each other, and that means multiplication. You could use this symbol. That means multiplication. Asterisk is a multiplication symbol as well. A lot of times, if you have a number next to a variable, that means multiply, or a variable next to a variable means multiply, right? And I guess one other thing I could have put there was a number outside the parentheses. So I could have put 5 times 7 like that. So that also means 5 times 7, right? Okay, then division. We have a few different symbols here. You have the classic division symbol there. You have the slash. You have the fraction bar, and then you have the long division symbol. Okay. And by the way, if you think of other things that I forgot, because I always feel like I'm missing one or two, then bring them to class, and we'll talk about those and make sure that everybody remembers those as well. And then addition, subtraction, I couldn't think of any other ones, but we have the plus there, and then the minus symbol there for subtraction. I also put these words that kind of go along with these different things. So exponents, also powers, multiplication. The word product is the result of a multiplication operation. Quotient is the result of dividing. Sum is the result of adding, and difference is the result of subtracting, right? So those are words that are associated with those particular operations.